All right, so where is that? There it is. So we're talking about rational functions and asymptotes. So an asymptote is basically kind of like a barrier that you can't cross. You can get infinitely close, but not actually cross it. Let me show you what it looks like. So for a vertical, you can never cross it. Some horizontal you sometimes can, but usually it behaves like a vertical. For example, right when I start, it starts freezing.
I got a question.
Yes.
When are we gonna see focus and directrix?
I don't know if it's in this class actually. I'll check for you. I'll check for you later though. That might come up if we do like hyperbolic functions or types of graphs, but don't know if that's in the scope of this class. I'll check soon. Okay, so right here. All right, so vertical asymptote happens whenever you have a value that's causing division by 0. So we know we can never put a 0 at the bottom. So the function starts to behave a certain way as it approaches 0. So as you can see, it starts to shoot off on the left side to negative infinity really quickly, but it never actually gets there. So it gets infinitely close, but never crosses. So that's essentially what an asymptote is. It's a value that the function cannot cross, and the closer it gets. So for example, 0.0001 is allowed, and it'll spit out a huge value way up here. 0 is not allowed. Negative, on the negative side, you can also plug in something like negative 0.0001 or whatever, get really close. But essentially, that's all that is. Now notice on this one, it also has a horizontal asymptote for this f of x. And we said on our notes here, if we're given a function, this is a rational function. It's just a fancy word for a fraction type function. A function that has a fraction is a rational type. Okay, so it all depends on the degrees on what's going to happen. If the degree of the top is less than m, the bottom, so if the degree on the top is bigger than the one on the bottom, you will have a horizontal at the x-axis. So notice on our you have this part written down here. You got this part. So I'm quoting this right here, number 1. If the top is smaller than the bottom, degree-wise, y equal to 0 is the horizontal asymptote. And that's what we have on this example, right? The degree on top is 0 because there's no x. The degree on the bottom is bigger. So notice that it doesn't cross the horizontal either. So y equal to 0, the x-axis, doesn't cross it. Okay. Does that make sense? Okay. All right, for vertical.
So what degree would this be? This graph?
For this example, the bottom would be degree 1.
Okay.
The top is degree 0. So since the bottom is bigger, you have a horizontal at y equal to 0, and then verticals are created by whatever makes the bottom 0. So if you read the vertical part here on your notes, right, we said anything that makes the bottom 0. So if you set the denominator equal to 0 and solve for x, that's going to be the value that creates the vertical asymptote. So in our case, it's just 0. Does that make sense?
So degree 1, I guess.
What's up?
So I guess it would be degree 1 because the x is degree 1.
So the degree of the denominator is 1. So m is 1, n is 0. But for this one, all you look at is the denominator and set it to 0 and solve. Okay, so that's the idea. And we'll do an example in just a second by hand. But there's also something called an oblique asymptote. Can you guys hear me okay? I don't know. Someone was saying the connection's a little off. I don't know if that's me or not.
I think you're fine.
Okay. Could be their connection. Okay. So oblique is just a slanted word asymptote type. So if it's at a slant, that's what we're talking about. These are when you have the numerator's degree bigger than the bottom. That's what we said on 3. So if n is greater than m, meaning the degree on top is bigger, you're going to have an oblique. Okay. So I'm just going to write C3 in horizontal. But I'm going to show you how to find it because that's what matters. So for example, I'm not going to show all the work, it's just a quick example. If you have a rational expression equal to this, and then we'll move on to examples, real examples. Let's say you have something like this, x cubed plus 2x squared minus 3x plus 5 over x squared minus 3x plus 5. Notice how the degree on the top is bigger than the bottom, right? The top is 3, the bottom is 2. Is that clear?
Yes.
If you were to divide this, using long division, you would end up with x plus 5 plus some remainder. Who cares about the remainder? The oblique asymptote
I can, okay, yeah.
oblique asymptote is y equal to x plus 5. So whatever you get as your quotient, that is the oblique. That's how you find it. Does that make sense? Okay.
And what do we do with the oblique answer?
What's up?
What do we do with the answer?
So if they on the questions we're going to get to just in a second, but they're going to ask. They're going to give you a function and they're going to ask you find horizontal, find vertical, but sometimes they may ask for oblique, or you might not have a horizontal. You will instead have this scenario. Okay, so it depends with the question and what they're asking. So let's get to the homework now. So this is just the big picture information you're going to need to do 4.1.
So I guess that the x plus 5 is like a factor, I guess.
This right here would be the equation of the oblique asymptote.
Oh, okay.
Okay. If the degree on the bottom is bigger than the top, y equal to 0 is the equation of the horizontal. Okay. If the degrees are equal, then the equation of the horizontal asymptote is y equal to a over b. So you just take the leading coefficients of the highest degree of the top and bottom and divide them. Okay. If the one on top is bigger, you're going to have to do long division. You end up with this scenario. The horizontal and oblique is the ones that are annoying. Vertical is the super easy part, which is not, I'm not going to worry about too much right now, but we'll do it all at the same time. Just a second. But any questions on these ideas?
Are we able to do the synthetic division as well if we wanted to like speed it up, I guess?
Let's see. If we did synthetic gives you maybe. Because when you do synthetic, you get the reduced form, right? So if that reduced form is linear, then yes.
Okay, so it just depends on like if it's linear, like the remainder.
Yeah, it depends on the question.
Like if it's equal to 0, you can probably do it, right?
Yeah. Yeah, so I'm trying to find an example where it would or would not work, we think. Yeah, I think if you did a synthetic, you'd have to get it all the way down until it's completely factored to the final form. Like if this was, let's say, a linear divisor and this was a cubic, you'd have to do it twice until you get that final result. Something linear. But we'll try it out in a second. Try it. Because it'd be nice, because or long division sucks, so it'd be nice to avoid it. But we may not be able to. Find out. We'll find out in a sec. Okay, so here's the homework. Okay, so the questions start here. The first few are theory. It says find all vertical and horizontal asymptotes. So look at your problem. What is the degree of the top?
So with those, I was doing those and I put the right answers, but it wouldn't accept them. It said they were wrong.
Did you type it in exactly the way they have it here?
They said in parentheses. I put 0,0. Was that a wrong way to do it?
Yeah, you have to put x because these are equations of lines. You have to put x equal to 0. It's not a value, it's an actual like line equation.
Okay, I didn't know that.
The 0,0 implies a single point, and that's not what we're talking about. So it's fair for them to mark you wrong, even though you technically knew what you were talking about.
Thank you.
Okay, so find out vertical and horizontal asymptotes. All right. Just writing it down over here. All right, so what is the degree of the bottom? And the top?
2 and 1. Well, 2 and 0.
So degree of numerator is 0. Degree of denominator is 2, right? Okay. So now look at the list of notes you said. What scenario do we have? Right, n is the degree of the top, m is the degree of the bottom. Is the top smaller than the bottom, or is the top bigger than the bottom?
It's 1.
Yeah, so it's gonna be 1. So horizontal right away y equals 0 because of that idea. The horizontal asymptote will be y equal to 0. Vertical asymptote. So you find this by setting the bottom to 0, and that's just going to be when x is 0, right? So x equal to 0 would be your equation. There's not much we can do here. Does that make sense? That's all they asked for, vertical and horizontal. Sorry, I got distracted. All right, you guys cool, number 1. The same question. Just going to put quotes so we know that's the same thing. F of x is 3 over x minus 7 cubed. So what is the degree of the top?
0.
0, yeah. Degree of the bottom?
3.
Okay, so it's the same scenario, right? So what is the horizontal asymptote?
0.
Yeah, but it has to be written as a line equation, right? To find the bottom, you just set this to 0. Cube root both sides will get me to here, right? Add 7 over. There is my vertical. Any questions on number 2? It's not too bad, right? Example 3. That would be the same question. F of x is equal to 2 minus 3x over 2 plus 7x. What's the degree of the top?
Uh, 1.
Yeah, it's gonna be 1. Degree of the bottom?
1 as well.
So when they're equal, what do we do?
We do number 2, the y equals a over b, right?
So you look at the coefficients of your highest degree and you divide them. So horizontal is going to be y equal to -3 over 7. Does that make sense? And then to find the vertical, you do the same thing we did up here. So take the bottom, set it to 0, solve for x. So subtract the 2 over, divide by 7. So x equal to -2/7 would be your vertical. Any questions on number 3?
How did you get the -3/7?
You take the leading coefficient of the top, the -3, and you divide by the leading coefficient of the bottom, which is the 7. You do this whenever the degrees are the same.
Okay.
So if the degrees are equal, just take the coefficient of the highest power on the top and on the bottom, divide. All right, you guys cool number 1, 2, and 3 then?
Yes.
This one here, we'll just look at it. This has no, number 8 has no horizontal because it's number 3 on your notes, right? Scenario 3. This is probably an oblique type. Same thing here, but they didn't ask us to find it, it looks like. So I'm not gonna worry about it. But you see how they got these, right? You set the bottom to 0. And then you factor. So x is 1, x is -1 because of the denominator. But you make sure you put x equals. Okay. Same thing here, solve for the bottom. Let's see if they ask for oblique or not. Maybe I give you extra information for fun. Interesting. Maybe later. These are all the same type that we just talked about. Okay, well, that's it then. We'll move on to 4.2. You guys have any questions on 4.1? So does the idea make sense? Can you find a horizontal or a vertical depending on the scenario?
Makes sense. It's easy once you know the formulas.
Yeah, just follow the definitions or be okay. All right, 4.2. They already changed the setting. So here they want us to, it's called graphs of rational expressions. I'm not going to force you to graph by hand. I'd rather you didn't. If you want to use graphic calculator, you can. The only thing I'm going to expect is this be able to do this information here. Right? Can you find the domain? Can you find the x and y intercepts? Those types of things are what I care about. Picking the correct graph is kind of whatever, because you can use many different tools to figure this out, right? The important part is understanding how you find domain. So let's do that. Let's do number 2. But before we start, so the rational, this is the parent function for the rational. So we should understand that it follows all the rules for reflections, right? If I do a horizontal shift, right? If I do +2, it goes to the left 2. If I do -2, it goes to the right. If I were to double it, it'll be more narrow. If I put a minus, it is reflected. So all those ideas that we talked about, same stuff. Okay. Now for domain, you can kind of just, you can see it yourself for this regular guy. Put the thing to it. So you can see that this function goes all the way to the negative infinity up until 0, and it skips, right? It's this point because it's undefined. So right after it goes to infinity. So basically the domain is all the x values. Which ones? Say in plain English, well, everything's cool except 0. So how do you write that in math notation? That's all you got to do. Just translate that to intro notation. It looks like here all they used was plain English, actually. Let me see if they use intro or not later. Yes, it's fine. But does that idea make sense? Do you see how you identify the domain based on what is not allowed? Ah, here we go. They do slant asymptotes here. So it wasn't pointless. Let's do one that has the oblique. Because we've pretty much done the other stuff already. This one seems perfect. So this is not, I mean, this is not until like late November, right? But I'm gonna probably remove some of the graphing questions because I don't really care for them. One thing I want you to know is, do you know what each graph looks like? And can you get information from the graph? That's what matters to me. So, given example 1, f of x equal to, let me switch over first. I'm going to write down this question. Okay. So by looking at it, do you agree that 0 would be a problem? Because of the horizontal or the vertical asymptote. Is that part clear?
Yes.
If we were to graph it, I think it should be very obvious. So right here, see how it's kind of slanted? This has an oblique, but you agree that the red, this left-hand side, the red graph here, does not cross zero. It's infinitely close, but never crosses it. And we know by looking at it that I cannot plug in zero here. But it looks like it goes off to infinity in both directions. So I only have one problem area, center. Okay. So to do that in interval notation, which you don't have to do, but I'm just going to mention it. We know that the domain visually is everything except zero. Everything over here is cool. Everything over there is fine. But not this 0 point. The way you would say that in plain English as well. Domain is all real numbers, right? Except x equal to 0. In interval notation, you would say negative infinity all the way up until 0. So put parentheses on 0 and then start right after 0. So putting parentheses means I do not include it. I stop right before and I start right after. So this is same. And I go on forever. So this section over here is 0 to infinity. This section over here is negative infinity to 0. Okay. Two sections. So that just created a gap that broke my domain into two parts. Does that make sense? So that's where part A comes from. The intercepts, well, let me write you a note. To find a y-intercept, you just plug in 0 for x, but I'm unable to because plugging in 0 down here would be a problem, right? We just said that. So that's why they have no intercept for y. To find x-intercepts, you set the function to 0 and you solve for x. And you're going to get two values, -1 and 1. Okay, so let's do that here. I'll make you a note here. To find x-intercepts, set the function equal to 0 and solve for x. So that's why you find x-intercepts for any function, not just these types. If you are unable to do so, then it doesn't have one, right? To find y-intercept, let x equal 0 and solve for f of x. So basically just let x equal 0 and see what you get. That's all you're gonna do. Okay. But I can't do it for this one, so there is no y-intercept. So no y-intercept because x cannot be 0. To find x-intercept, right? You set this guy to 0 and you solve. So notice how, do you agree that the denominator is not going to make any difference? The denominator will never make the 0. It's going to happen up top, right? Only the top really matters. The bottom will have will make no difference. So x will equal to -1 and x will equal to 1. So this will be the x-intercept. Okay. But as a point, these are written as -1, 0 and 1, 0. Because intercepts are actual locations, they're coordinates. Okay, so this is part A right here. Right there. This is part B. Part C is find the asymptote. Okay. Find any vertical or oblique. They use the word slant, which is the same thing. You agree that the vertical is simply x equal to 0. The degree of the top is bigger, so I need to do my division, right? We can try synthetic. Our divisor will be 0. Let's try that. It can be done, but I've never divided by 0 before. Well, I'm not dividing, I guess, but I'm doing synthetic division with a 0. It's super weird. So we got to add the missing x and the constant. Oops, sorry. Just the coefficients. The coefficient is going to be 1 for the x squared, 0 for the x, and -1 for the constant. Bring down the 1. See if this is legit. So when I divide it, I'm going to get, so I can note here, x squared minus 1 over x is equal to x minus 1 over x. So the oblique is this piece right here. We'll call it the slant, I guess. Y equal to x is the oblique in this case. So you can do synthetic. You just need to make sure you understand what you're dividing by and what the result means. If you just do a straight up long division, whatever you get as an answer is the equation. So you choose whatever you think is easier for you. I don't know. Part C makes sense though. Okay. Right. Let's see what else we got. I don't want to spend too much time on graphs. I think they're whatever. Let's see here. Where are we? So this is the end of, oh yeah, actually, this is the end of the material for the first exam right here. So everything up until 4.2 is exam 1. So I combine unit 1 and unit 2 into one exam. So don't forget. I don't remember the date I told you, but it's on there.
Are the questions on the test going to be like in order based on the chapter?
Let me see. Check. Wait a second.